All right, let's look at solving radical equations and equations with rational exponents. All right, so when you have a radical equation, what you need to do first is isolate the radical. So I'll subtract 3 from both sides and get the square root of x minus 1 is equal to x minus 3. Okay, great. And now to undo the square rooting, you can square both sides of the equation. Okay, so we would get x minus 1 is equal to x minus 3 squared. And just be careful, it's a common mistake just to want to square each of the x and the 3, but we actually need to distribute the x. So we'd get x squared minus 3x, and then we'll distribute the negative 3. So we'd get another negative 3x and then plus 9. All right, so square that out. And next we're going to set it equal to 0. So I'm going to add 1 here, and I get x equals x squared. Looks like I could combine those to get negative 6x plus 10, and then subtract x from both sides, and I get 0 is equal to x squared minus 7x plus 10. And now just check, sometimes we can factor. So you might need to use quadratic formula, but let's see, it looks like I could factor that as 5 and 2. Both of them need to be negative to give this a positive 10. And now we're ready for the zero product property. Okay, so that would give us x is equal to 5, because to get a 0 here we would need a positive 5, and then to get a 0 on this one we would need a positive 2. And there we've got it, done and done. All right, now the last step is that we always need to make sure that we check. Really important. Okay, so I go back to the original equation. Square root of x minus 1 plus 3 is equal to x. Okay, so the first one I'm going to check is x equals 5. Okay, so square root of 5 minus 1 plus 3. Is that equal to x, which is 5? And I would get square root of 4, which is 2, plus 3 is equal to 5. And that one works. So x equals 5 is a true solution. And now let's check x equals 2. So I would get the square root of 2 minus 1 plus 3 is equal to x, which we're checking for 2. Let's see, 2 minus 1 is 1. Square root of 1 is 1. 1 plus 3 is 4. Is that equal to 2? Nope. So x equals 2 is not a true solution. All right, so we just have one solution on this. X equals 5, and we are done. Now on this one I have 2 square roots, and so I'm going to do the same thing. I isolate one of the radicals, which in this case it's already done, and then I'm going to go ahead and square both sides, just like if we had only one radical. So squaring undoes the square root, so I'm left with 1 minus 2x. Those are inverse operations. And now we have to be really careful here and distribute, let's see, 2 plus square root of 1 minus x. Okay, so I'm going to distribute my 2, and I would get 4, and then plus 2 times the square root of 1 minus x. And then distributing that, I would get another 2 times the square root of 1 minus x, and distributing that square root of 1 minus x, I would get plus the square root of 1 minus x times itself, so that's the same thing as being squared. Squaring undoes the square root, so this is left with 1, or that simplifies to 1 minus x. All right, let's see, I gotta copy my 1 minus 2x on the left side, and combining like terms here. So I've got 4 from here is equal to, or plus, I've got 2 square roots of 1 minus x plus 2 more of them, so that gives me 4 of them. And then that would be plus this 1 minus x. Okay, and now I can get my 1 and 4, just add those up. So I've got 1 minus 2x is equal to 5. And then I'm going to just go ahead and write that minus x so that it's easier for me to see what's going on. Okay, now the next step is to isolate a radical. Okay, so I need to get everything on one side except for just that radical. So I'm going to subtract from 5 from here, and I would get -4. And then I'll go ahead and add x as well in this step. So I'd get -4 minus x is equal to 4 times the square root of 1 minus x. Great, and now I'm ready to square both sides. I've isolated my radical term. Okay, so I would get -4 minus x times itself, and so because there's subtraction in here, I need to make sure that I distribute. So -4 times -4 is positive 16. And now we have -4 times -x is a positive 4x. And we have another -x times -4, so that'd be another positive 4x, and then plus x squared. And here I get to just square both the 4 and the 1 minus x. So I would get 16 times 1 minus x. And notice that because this is multiplication, I square both. If this had been addition, that it would have squared out a little bit differently, where I would have needed to distribute the 4 to both and then the square root of 1 minus the square root of 1 minus x to both. Okay, so if there's addition, you need to distribute. If there's multiplication, we don't need to worry about that. Okay, and now I have a quadratic equation, so I'm going to set it equal to 0. I'm going to factor that 16 in first, and I'm going to combine my x's. So I've got 16 plus 8x plus x squared, and now I'll set it equal to 0. So add 16x to both sides, and that would give me 24x. Subtract 16, as I set that equal to 0, so those cancel out, and I've got plus x squared is equal to 0, and then I can factor my x out, and now I can use the zero product property, giving me x equals 0 or x equals -24. All right, so let's see what we did. We isolated the radical, which was already done for us, and then we squared both sides. Then all of this work here is us simplifying each side of the equation so that we can isolate the radical again, which is what we got here. Then we squared both sides and now set equal to 0 and solve. And the final step is to check. So we go back to that original equation, 1 minus the square root of 1 minus 2x is equal to 2 plus the square root of 1 minus x. Okay, and I'm going to check both of these. X equals 0. So here we go. 1 minus 2 times 0, that's just square root of 1, which is 1. And then I have square root of 1 minus 0, so that would be 2 plus square root of 1, which is 1, which is 3, which does not work. So that one is not a true solution, and then we can check x equals -24. So we would get square root of 1 minus 2 times x, which is -24. And that gives us 1 plus 48. Square root of 49 is 7. And then we have 2 plus the square root of 1 minus x. So that would be 1 minus -24. Which would be 25, so I would get 2 plus 5, which is 7. So that one does work. That is our one and only solution here. And we're done. All right, I am going to solve this equation with a rational exponent. So my goal is just to get x, which is the same as x to the 1. So I can do anything I want to an equation as long as I do the same thing to both sides. If I take this left side to the power of 3/2, I would get x to the 6/6, which just simplifies to 1, which is my goal. Okay, so I'm going to take the power, the reciprocal power of whatever's happening to x. Okay, and then I use the definition of rational exponents. The numerator is the power, and the denominator is the kind of root. So I would take the square root of 4 and then all of that to the third power. So I get x is equal to, let's see, square root of 4 is 2, and then 2 cubed is 8. So there's my solution, and I just want to do a quick double check. So 8 to the 2/3, does that really equal 4? Let's see. Denominator is the type of root, so the cube root of 8 squared. Is that equal to 4? And it is, because cube root of 8 is 2, and 2 squared is 4. So that one checks out. All right, so let's see. I have rational exponents on this. If I had an equation like u squared minus 3u minus 4 equals 0, that would not be a very hard equation to solve, right? We could just factor and then use the zero product property. Okay, so it's actually not going to take us that much work to rewrite our original equation into this nice quadratic form. If I give myself a new variable and I just let this new variable u be equal to x to the 1/3, then here I have x to the 1/3. So this would be 3u. All right, now let's look at this one, x to the 2/3. Well, if I take x to the 1/3 and square it, I get to multiply powers there, so I would get multiply straight across. I get 2/3, and that's what I was given here. Okay, so that is exactly what we get when we take and we square both sides of this equation. So that is equal to u squared. All right, so I'm going to substitute u squared in there. Okay, and now I'm ready to solve. Using the zero product property, I would get u equals 4 and u equals -1. And now what you need to do is substitute this definition of what we let u be, put that back into your equation. So u was x to the 1/3, and here u is x to the 1/3. So I would get x to the 1/3 is equal to -1. And now I'm going to solve. To do that, I need to take both sides to the reciprocal power. So it would be 3/1, or just that's cubing both sides. So I would get x equals 4 cubed, which is 64. And then here, if I take and cube both sides, I get x equals -1. And both of these do end up checking out when you plug them back into the equation. And so that is done.